welcome to the deep dive. Today we're taking on one of the most fundamental questions humanity has ever posed.
Really, it's the big one.
What exactly are those twinkling lights up in the sky?
It's a profound journey, you know. It starts in childhood for all of us, but it also extends across, well, millennia for our entire species. We're diving into how we went from just myth and pure speculation to actually wrestling one of the universe's great secrets from nature.
Yeah, we're tracing that whole evolution of thought. Our source material really chronicles the path from, early mythology to one of the biggest realizations ever.
Which is?
That the stars are distant suns, and our Earth is simply one planet among many.
And the mission of our deep dive today is to really get that intellectual shift. I mean, there's this core tension between a universe governed by, unpredictable whims.
Gods, basically.
Exactly. The old texts would say gods were used to express the concealed, remote, unknown causes of things. We just filled in the blanks of our ignorance with reverence.
And the mission of science, that Ionian spirit we're about to get into, is just the absolute rejection of that comfort. It's what drove the philosopher Democritus to say, I would rather understand one cause than be king of Persia.
That singular focus, to find the truth, no matter the consequences, no matter the power it gives you, that's the engine of this whole story. We're tracing the shift from chaos to cosmos.
From a universe of chaos to one of internal order.
Precisely.
So let's start where knowledge started. Let's go back to the childhood of genus Homo.
I like that framing.
Picture our ancient ancestors, right? The hunter folk.
Yeah.
They're looking up from the security of their fire. They understood survival. They got rules, and they certainly understood flame.
Yes, a strong, living, but, a simple entity they learned to capture and feed.
And this moment of curiosity, just looking up at the vastness, it's often described as intellectual recapitulation.
Right. The idea that your own individual development, like your own moment of childhood curiosity, it kind of mirrors the collective history of how our species first thought about the world.
So when those hunter folk looked up, their first theories about the cosmos were just delightfully grounded in their reality. What did they know?
Campfires.
Campfires. So the first explanation was that the stars were just distant campfires, lit by other tribes, too far away to fall down.
A very literal, very practical explanation. The second one, though, is much more evocative. It suggests this kind of cosmic skin.
The animal hide.
Yeah, that night is this huge black animal hide thrown over the sky, and the stars are just holes poked in it, revealing this universal flame of power that's just everywhere underneath.
My favorite, though, has to be the one from the Kung Bushmen of the Kalahari Desert. It's so elegant.
Oh, the backbone of night.
The backbone of night. They believe the Milky Way was a literal spine, holding up the darkness to stop it from crashing down on the world.
These metaphors are powerful, but they're still just stories. And eventually, these poetic explanations, they gave way to personalized beings.
The strong flame becomes a sun god.
The storms become angry beings. The universe gets capricious and dangerous. Think of the Greek myth for the Milky Way, the galaxy. It's the milk of the goddess Hera, squirted across the heavens.
Then something radical happened.
Yeah.
Around the 6th century BC, there was this incredible awakening in the Greek colonies of the Eastern Aegean, an area we call Ionia. And suddenly, people began to believe that the universe wasn't capricious, that it was ordered, and therefore knowable.
And that is the birth of the scientific mindset. It's the definitive revolution from chaos to cosmos. Ionia wasn't just, geographically lucky, socioeconomically positioned for this. It was a crossroads where ideas from Africa, Asia, Europe, they all cross-fertilized.
They also adopted the Phoenician alphabet, which was huge. It allowed literacy to flourish outside the control of the priestly classes.
And here's the absolute key, I think. When they were faced with all these competing gods like the Babylonian Marduk challenging the Greek Zeus, they had this crucial realization.
They could look at the world
and understand how it works.
Without appealing to the God hypothesis at all.
That's the leap.
And the figurehead of this radical shift was Thales of Miletus. He was the first Ionian scientist.
Right. We know him for predicting a solar eclipse, proving foundational geometric theorems. But his real breakthrough was something else.
It was explaining how dry land formed from water.
Exactly. He looked at the silting at the Nile Delta where the river deposits material and creates new land. And he just concluded that dry land formed from water through this observable natural process. He was explicitly leaving Marduk out.
It was a material explanation. It was rooted in what you could see, not in dogma.
And just to prove that these philosophers weren't, absent-minded dreamers, there's that great anecdote about
So
him.
with the olive presses.
Right. He used his skills to predict a bumper olive harvest, cornered the market on all the olive presses, and basically proved that, yeah, philosophers can be rich, but their true ambition is somewhere else. It's in understanding causes.
And that material focus just continued with Anaximander of Miletus. He was one of the first known experimentalists.
Using a simple shadow from a stick to measure the year and the seasons, so simple.
But his cosmic view, that was truly revolutionary. He dared to suggest the Earth is just, suspended at the center of the universe by itself.
Equidistant from everything else on the celestial sphere. It needs no support, no giant turtle, no pillars, nothing.
The Earth just hangs there.
And he didn't stop. He also basically anticipated evolution. He argued that since humans are so helpless at birth, we must have evolved from more self-reliant animals. He even proposed that life arose from mud, maybe a spinefish. These guys didn't just speculate, they observed and derived.
And this Ionian tradition, it was so defined by its hands-on approach. I mean, the practical application of their geometry was stunning.
Oh, like on the island of Samos, Polycrates orders a kilometer-long water tunnel cut through a mountain.
And they meet almost perfectly in the middle. We also have figures like Theodorus, who's credited with inventing the key, the ruler, the lathe.
Central heating.
Right. Theoretical knowledge and practical labor were one and the same.
And that practicality, it led to these crucial discoveries about the invisible world. You see this with the physician Empedocles.
Another one who anticipated Darwinian selection. He suggested life survived based on craft or courage or speed.
But his most famous act was that simple experiment with the clepsydra, the water thief.
Right, the brazen sphere with holes and an open neck. If you try to dunk it while covering the neck, the water won't go in.
And if you pull it out of the water with the neck still covered, the water stays put.
So why is this so important?
Because it demonstrated that something invisible, something you couldn't see, was blocking the water. A material substance.
Air.
Air. Empedocles showed that a simple, repeatable observation with a household object could reveal these deep truths about the material reality of the world.
And this quest for the unseen, it kind of culminates in Democritus of Abdera, one of the greatest minds of the age. He believed that understanding and enjoyment were the same thing.
Democritus gave us the word atom, which means unable to be cut. His core assertion was so radical, nothing exists but atoms in the void. He even got close to differential calculus, arguing that if you slice a cone, the tiny difference between the cross-sections implied this irreducible roughness.
The scale of atoms.
Exactly. And his foresight was it's almost unbelievable. He looks up at the Milky Way and reasons that it's not a backbone or spilled milk, but it's composed of unresolved stars.
Long before any telescope. That's seeing the universe with the eye of reason.
But this period of free inquiry, it was short-lived. As the material explanations grew bolder, the political and cultural tides, they started to turn.
Yeah, we see this so clearly with what happened to Anaxagoras. He was an Ionian experimentalist brought to Athens by Pericles.
And Anaxagoras taught that the moon shines by reflected light, that it had mountains, and crucially, that the sun and stars were just fiery stones, not deities.
Sounds like textbook science to us now.
But for believing the sun was a stone, Anaxagoras was imprisoned for impiety. And this wasn't really a religious verdict so much as it was a political attack on his patron, Pericles. The message was clear. There are limits to material explanation, and they're set by those in power.
Wait, so if the Ionian Awakening was so revolutionary, why was Athens, this supposed center of philosophy, so quick to suppress the idea of a fiery sun? Did the commitment to cosmos only apply to geometry and not, cultural beliefs?
That's the essential question, isn't it? The materialists were challenged not just by politicians, but by other intellectual traditions, most notably the Pythagoreans.
Right. Pythagoras was brilliant. He proved the famous theorem. He gave us the word cosmos, but he established an anti-empirical tradition.
Ah, the belief that nature's laws could be figured out purely by thought.
Exactly. No need for observation, no dirtying your hands with experiments.
The Pythagoreans were obsessed with the perfection of whole numbers and ratios. So when they used their own theorem and discovered the irrationality of the square root of 2, that a fundamental relationship in geometry couldn't be a perfect ratio, it caused a huge crisis.
It shattered their whole numerical foundation. And instead of sharing this profound discovery, what did they do?
They suppressed it. They kept the knowledge of irrational numbers and even the existence of the dodecahedron secret. They replaced curiosity with this elitist, rigid tradition.
This suppression, combined with a much larger socioeconomic issue, is what helps explain that 2,000-year scientific decline,
And this is the powerful thesis from the historian Benjamin Farrington.
which argues that the pervasive slave economy was the root cause of the stagnation.
It's a staggering implication. Scientific experimentation demands manual labor, measuring, observing, building things. In a society based on slavery, the leisure class, the only ones with the means to do science viewed manual work as beneath them. It was literally the work of slaves.
So they abandoned the Ionian experimental method because it required dirtying their hands.
Absolutely. The existence of slaves removed both the necessity and the dignity of that kind of labor for the elite. It killed the economic motive and the intellectual method for 2 millennia.
Wow. That is an incredibly costly period of lost human progress.
It just fundamentally shifted the focus from hands-on testing back to pure thought, reinforcing that rigid Pythagorean tradition over the dynamic Ionian one.
Okay, so we fast forward through this immense period of stagnation to the last flickering light of Ionian genius, Aristarchus of Samos.
Working at the Library of Alexandria, 3rd century BC, he is the true restorer and confirmer of the heliocentric hypothesis.
Sun at the center.
Right. Aristarchus observed the Earth's shadow on the moon during an eclipse and figured out that the sun had to be far, far larger than the Earth. So he reasoned it's absurd for this enormous thing to revolve around our tiny Earth. Therefore, the sun must be the center.
And he understood the cosmic scale this implied. The fact that they couldn't observe any stellar parallax, the apparent shift in the star's position as the Earth moves,
Was actually consistent with his view. But it meant the stars had to be much, much farther away than anyone had ever imagined.
light years away, a distance they had no way of measuring.
And so his brilliant idea was deemed impious, and it was suppressed for 1,800 years until Copernicus revived it.
But the spirit of Ionian experimentation, it did eventually return. Nearly 2,000 years later, Christian Huygens devised this ingenious way to estimate that distance.
Huygens used the Ionian method. Simple tools, radical insight. He took a tiny piece of brass with a hole in it, precisely 128,000th the apparent size of the sun.
Okay.
He then compared the brightness of the sun's light coming through that tiny hole to the brightness of the star Sirius.
And what did that reveal?
He correctly reasoned that Sirius was about 28,000 times farther away than the sun. It was a quantitative, verifiable measurement. It showed that stars were mighty suns light years away.
The legacy of Aristarchus is this continuous demotion of humanity's privilege in the cosmos. And it didn't stop there.
Not even close. In the early 20th century, the demotion continued on a galactic scale. Harlow Shapley in 1915 used variable stars, these stellar standard candles in globular clusters.
And by measuring their distance, he proved that our solar system is not at the center of the Milky Way.
Nope. We're a considerable 30,000 light years out, on the fringes of a spiral arm.
So not only are we orbiting the sun, but the sun itself is just out in the cosmic suburbs. And then Edwin Hubble delivered the knockout punch in 1924.
Hubble used another class of variable stars to confirm that those faint, cloudy, spiral nebulae they saw through telescopes, they weren't gas clouds in our galaxy.
There were other island universes. I love that phrase from Kant.
It's so evocative. Immense galaxies like M31, Andromeda, which is 2 million light years away. It proved we live in a universe with potentially 100 billion galaxies.
The scale is just staggering. So if we synthesize this whole journey from thinking the stars were campfires to knowing they're suns in a universe of 100 billion galaxies, we're left with a pretty profound conclusion.
That conclusion is beautifully summarized in the material. We live on an insignificant planet of a humdrum star lost between 2 spiral arms in the outskirts of a galaxy that is one of 100 billion. Every scientific step since Aristarchus has moved us farther and farther from center stage.
This knowledge is so humbling, and yet it's empowering. I mean, think about the old geocentric ideas. Even 2,200 years after Aristarchus proved it wrong, we still say the sun is rising and setting.
That linguistic laziness, right, that commitment to the easily observable lie, it just shows how hard it is to shake off old ways of thinking, even with overwhelming evidence.
It really does.
But the profound significance of this whole perspective is that, well, if we want our planet, our species to be important, we make it significant by the courage of our questions and by the depth of our answers.
Spirit of Ionia.
The spirit of Ionia. It's the recognition that truth, not our position in the universe, is what gives our existence meaning.
What a magnificent thought. If you are ready to continue your cosmic voyage, if you're ready to set sail for the stars, maybe start by just asking that question that brought us all here today.
Always keep asking the hard questions.
Thanks for diving deep with us. We'll see you next time.